Hello everybody. Today we are going to do LeetCode problem number 67, which is add binary. So if we take a look at this, it says given two binary strings A and B, return their sum as a binary string. The first example, A is 1, 1 and B is 1, and the output is 1, 0, 0. Now, how in the wide world of sports did they get that number? Let's go back, see if we can't figure that out. All right, so let's take the number 432 and base 10. So we are used to base 10. Whether we know it or not, we work with base 10. So each digit can have an integer value ranging from 0 to 9, which is 10 possibilities. So take 100. That can be expressed as 10 to the second, which is where we get the base 10, which is 10 times 10. The value 10 is 10 to the first power, which is 10 times 1. And then 1 is actually 10 to the 0 power, which is just 10 times 0.1. So each time you move the decimal place 1 to the left. We can also think of it in terms of hundreds, tens, and ones. So there's 400 plus 30 plus 2. So if you take 400, you can actually think of that as 10 to the second power times 4. And the 30 is 10 to the first power times 3. And 2 is 10 to the 0 power times 2. So this is how we currently use base 10. So binary is what's called base 2. What does this mean? So we're used to 10x. So 10 to the first, 10 to the second. Binary is 2 to the x. So 2 to the first, 2 to the second, blah, blah, blah. So each digit can have an integer value ranging from 0 to 1. Two possibilities. The only two numbers that can be in binary are 0 and 1. So 10 to the second would look like 2 to the second. So I'm not, obviously 10 to the second doesn't equal 2 to the second. I'm just saying this is how the second power would be represented in base 2. The 10 to the first is 2 to the first. 10 to the 0 power is 2 to the 0. So let's try to convert 5 to binary. So we have 2 to the second, 2 to the first, and 2 to 0 power. So 2 times 2 is 4, 2 times 1 is 2, and 2 times 0 is 1. Or 2 to the 0, anything to the 0 power is 1. Okay, so the way we look at this is how many times can 4 go into 5? Well, the answer is 1. And then you subtract 4 from 5 to get 1. So how many times can 1 go, or how many times can 2, this number, go into 1? And the answer is none. And then how many times can 1 go into 1? And the answer is 1. So the binary representation of 5 is 101. And congrats, we've just done binary. All right, so now we'll go back to our example here. So we have 1 and 1 and 100. So let's go through that. Actually, let's go through that now. So we have the number 3. Actually, let's do this first. That's number 3 in binary. So we have 2 to the first and 2 to the 0 power. So 2 to the first equals 2. 2 to the 0 equals 1. How many times does 2 go into 3? Once. And then how many? 3 minus 2 is 1. And 1 goes into 1 one time. So we're going to use this in our addition problems. The other number we're going to use is 2. So 3 is 1, 1 in binary. So 2, using the same logic, 2 and 1. How many times can 2 go into 2? Well, it goes in there once with nothing left over, so then it's 0. So 2 is 1, 0 in binary. And these are the two numbers you're going to have to remember. So using our cheat code here, 3 is 1, 1, 2 is 1, 0. So in standard addition, we take 7 plus 5 to get 12. So we drop the 2 there and carry the 1. And add 1 and 1 to get 2, the 22. So the same thing works in binary. So this is the first LeetCode problem. So let's try and do this. So we have 1 and 1, which gives us 2. But 2 is really 1, 0 in binary. So we're going to drop the 2 and carry the 1. And then we have another 2. So 1 plus 1 is 2. 2 in binary is 1, 0. So we have 0, we carry the 1, but we don't have anything left, so we just add that. So there is the 100. So if you go back to example 1, 100 is the answer. So let's look at example 2. We have 1, 0, 1, 0 and 1, 0, 1, 1. So we look at that, 1, 0, 1, 0 and 1, 0, 1, 1. So let's try and do that one. 0 plus 1 is 1. No carry. 1 plus 1 is 2, so we're going to drop a 0, carry a 1. So here we have 0 plus 1, just 1 with no carry. And then finally 1 plus 1 is 2, which is 0, 1. I'm sorry, 1, 0. So we drop the 0 and then the 1. And 10101 is the answer for the second example. Alright, so let's go back to this. So how are we going to do this? Well, the first thing we're going to do is we need to build the binary number, and we're going to do that using string builder. If you add, because we're going to be appending to the string, you always want to use string builder. If you just concatenate a string, it actually creates a new string. It's called immutable. So it creates a new string each time, it uses more memory. Okay, so the first thing we're going to do is get the length of the first number minus 1, because as we know, arrays are 0 based. And I got to start at the end, that's confusing. So to get the least significant digit, and we'll put that in variable I. And we'll do the same thing with the second number and put it in variable j. Then we need to define the carry variable for any remainders that we need to throw up top. So we're going to loop through both numbers until both are less than 0. So in other words, we run out of numbers in j, there might still be numbers in I, so we want to make sure we go through both of them. So we're going to define a sum variable. This is going to add the two numbers and store them until we can figure out what needs to go into the string builder. Because, for example, if you have 1 and 1 equal 2, we can't put 2 into the string builder because we can only put 0s and 1s. So we need to deal with the remainders in that case. So the first time through, the carry is 0, so sum will be 0 in this case. So if I is greater than 0, we need to add the value of I to sum. And if j is greater than or equal to 0, we need to add the value. It means that j still has a value, and we'll add the value of j to sum. So here's how we deal with zeros and ones. So we're going to insert the remainder of sum, which is modulus. Modulus gets the remainder. We're going to do mod 2 because we're doing base 2. We're going to stick that in the string builder. So in the case of it, let's say I is 0 and j is 0, 0 mod 2 is just 0, which is fine. And let's say I is 0 and j is 1. Well, 1 mod 2 is just 1. What we really need to be concerned about is the 2. So if we have 1 and 1 is 2, because we can't stick 2 into a binary string builder, 2 mod 2 is 0, which is what we want anyway, because 2 is 1, 0. So we would drop a 0 here and then carry the 1. And then if the carry, or if the sum is greater than 1, we have to assign 1 to the carry. So in the case where it's 2 or 3, we'll have a carry. Then we're going to end the loop. And at the end, if we still have a carry, we have to add 1 more to the string builder. And then we convert string builder back to string and return it. All right, let's tackle the coding. First thing we're going to do is build that string builder. Standard naming convention, SB, see that a lot. New string builder, instantiate it. So we're going to define the variable I and assign it to the length of A minus 1. Same thing with J is the length of B minus 1. And we'll assign, or we'll create the carry variable and assign it to 0. All right. So while I is greater than or equal to 0 or J is greater than or equal to 0, either or, first thing we do is assign the sum equal to the carry. And the first time through, the carry is, or the sum is 0. We don't have a carry. Okay, this is the fun part. So if I is greater than or equal to 0, sum plus equals a char at I minus 0. What the heck does that mean? So a char at is going to grab the character at I, which is the least significant digit. Now the minus minus means after it gets the value of I, it's going to decrement it. If you put the minus minus before I, then it will decrease the value of I before using it. But because it's behind it, it decrements it at the end. Now, we subtract a character 0. So when you grab the character 1, in decimal, it's actually 49. And so we subtract character 0, which is represented 48 in decimal. So you're just subtracting 48 from 49 to get 1. And we'll see that in the debugger. But you could actually do minus 48 here, but that might be a little more confusing than this already is. Same thing with J. We're going to do J is greater than 0 and subtract the character 0 from that. So if I is, the character at I is 0, then it's just going to be 48 minus 48, which is 0, so that's fine. But if it's 1, then it's got to be 49 minus 48. So it works both ways. Okay, so here's this, the sum mod 2 we were talking about. We're going to do an insert, and we're going to do a 0, which means it's going to stick it in the first position. So string builder actually, if you were to not have an offset, it would just put it, it would actually stick it in there backwards because it doesn't know how to stick it at the end and work in reverse. But if you use this offset, then it works just fine. And so sum mod 2, so this will stick either 0 or 1 into the string builder. And then if the sum is 2 or more, then we're going to put it in the carry. All right, and then if the carry is greater than or 0 at the end, like we talked about, then we've got to insert offset 0, or at offset 0, at position 0, insert a 1 there, because we have a remainder of 1 that we need to drop down. And then return string builder to string. And that is all she wrote. All right, let's debug this and see what we get. All right, here I have used the 1, 1, and the 1. So let's go through this. So I is a length, a length. So we see down here, I is 1 and J is 0. We're going through here, sum is 0. Okay. So if I is greater than 0, which is true, so we take, and you look down here, see it has a 1 there, because both I and J are currently 1. I mean, we're dealing with the least significant, so it'll be the 1 here in this case, and then B only has 1 value. But they're both 49, so that's why we subtract the 0. Okay, and now we get index out of bounds exception because J is now less than 0. Okay, so we offset this. The sum, what is the sum? The sum is 2, so now we're going to mod that. So stick a 0 in the string builder, which is 0, and we're going to carry over a 1. The carry is 1. The string builder has the value 0 in there. So we're going to go through this one more time. Now we have to add 1 to the sum because we have that remainder up top there. And then we add, the sum is now 2 because we had the 1 in string A. Then we'll offset that and add a 0, and So here now, in string builder, we have 0, 0. And we're through the loop, through the while statement. But because the carry is greater than 0, we're going to insert that 1. And we return that, and you can see the result is 1, 0, 0, which is what we expect. All right, let's run this through LeetCode. See what we get. Expected value, and we are faster than 75%, and use less memory than 69.56%, so that's pretty good. All right, the last thing that we always do is go through the space and time complexity. So we have two inputs, n plus m. So this is the big O complexity, is O of n plus m. And for the space complexity is the same thing, n plus m. As the inputs get bigger, uses more memory, also takes more time. Okay, that's it. Let me know how I did. Hopefully your interviews go well, and we'll see you next time.